Is that audible? Good evening, everyone. Is it audible to all? So we will start the lecture just after 1 minute. Let me share the link with others so that they can join the class. Good evening, Shivu. Good evening, Tashif. कल कहाँ थे तौशीफ तुम? Yesterday you were absent, right? Good evening, Shundram. Just we'll start the class after King Shukte. Good evening. After 1 minute we will start so that other people can join the class, right? Good evening, Jitendra. ओके तौशिफ, फेयर। PYQs का सेशन है हमारा this next Monday, coming Monday we will have the PYQ session of vector analysis, vector calculus from the last part है ना, वो remaining है हमारा. We will do that for sure. Even today I myself was like trying to solve questions because due to the ill health I was not taking the offline lecture last 2 days. But anyways, any doubt from the previous lecture, anyone? Good evening, Jiten, Amit, everyone. Good evening. So, anyone have any doubt from the previous lecture? Should I continue? Fair. So, just a quick reminder, recap from the previous lecture. I had told you different multiple examples, practical examples, why this group theory is so much interesting or this abstract algebra. Yesterday I told you कि whenever you want to study the abstract algebra, the very important preliminary is you have to study about the set theory, right? Okay, Chandra. So whenever you have a set S, right, you have a binary operation. Yesterday I told you what does that mean by binary operation. Means suppose that if you have this operation and you apply that operation on the set S cross S, means between two elements of S, if you apply this operation, you get the any third element of the set capital S itself. So so it is called the binary operation on the set S. Fair. After that I told you whenever you equip a set, and obviously that set should be non-empty. What, dear fellows? Set is non-empty. If you equip a binary operation with the set, you got an algebraic structure, right? Then I told you when this algebraic structure is gonna be a group. If some certain properties or axioms are satisfied, right? So in the first half of this lecture series, we will be dealing mainly with the group theory. As yesterday I told you that if you are comfortable in the group theory, then ring theory, integral domain and field is just the replication of that. Fair? So please put the focus here. So let's start today from the set. So that yesterday I told you the segments as well, कि there are some preliminaries which are required to study group theories. Fair? So today's lecture is gonna be devoted for this at the top priority. After that, if the time come like allows us, we will start the group theory as well today. Fair? So please don't miss this. Although you may feel ki sir, these basics I know from my childhood. Yes, I know that you know, but you don't know how to utilize that in group theory. So no matter you feel ki okay, you know everything, still you have to be attentive over the words. Fair? Because ultimately this is gonna reflected in every lecture of group theory. So have patience and be continuous in the lecture series. Fair? So these preliminaries, this is the chapter for today. Fair? And the first topic which we are taking today is, please write it, equivalence relation. Fair? And obviously, to study about the equivalence relation, we need to have some basics. Okay? So I will see, I'll be like in the flow. If you have any doubt, you can like let me know. Before that, I must study the Cartesian product of two sets. For example, if you write the Cartesian product of two sets S1 cross S2, fair? Let's say you product S cross S dash, you got tuples, right? For example, if you want to know what is A cross B, where A is the set 1, 2, 3, B is the set AB, let's say AB only. So this set will be consisting of the tuples. What those are called? Tuples. Two tuple, right? So 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A, 3 comma B. And why I have told you this thing here, the reason is, अभी देखिएगा, what you can say, you can think like, ध्यान से देखेंगे, one is related to A, one is related to B, two is related to A, two is related to B, and so on. So means, and what is the relation? That is the Cartesian product. So the topmost part is the Cartesian product of two sets. अब देखेंगे what you do. Suppose that you want to define a relation from set A to set B the relation R1, let's say, such that कि the relation R1 exists for, देखेंगे, 1 is related to A, 2 is related to V. Suppose that you defined another relation where 2 is related to A, 3 is related to A only. You may define some other relation where 1 is related to A, 1 is related to B, 2 is related to B. So in this manner, you can define different relations from set A to B, right? Can you observe one thing? A relation from A to B is a subset of A cross B, right? Is this clear now? Fair. Abhi, what I do, I just write another pointer, that is relation on a set. So when I talk about relation on a set S, basically you are talking about relation between S and S itself, right? For example, uh, let S equals S1 comma S2 comma S3, and you define a relation over S itself, that is like S1 is related to S1, S2 is related to S2, S3 is related to S3. You may define another relation ki where S1 is related to S2, S1 is related to S3, and so on. So thing is, whenever you talk about Cartesian product, after that there is a subset of Cartesian product that is called relation. ठीक है? A relation is just a subset of Cartesian product between those two sets. Relation on the same set, कहने का मतलब होता है you are taking relation between S and S itself, but the relation will be defined like the tuples. Fair? So when I keep on moving like this, I may get the function as well, right, my dear fellows? Since we are studying in a flow and I am trying to generate the interest for maths, how it originates, so I am like moving like this. So when I talk like function, so you can say spatial relation. And how it is a spatial relation, ध्यान से देखेंगे, if each element of A is related to some unique element of B. कहने का मतलब, फॉर एग्जाम्पल अगर आप देखेंगे इस रिलेशन को, हियर R1 को देख लीजिए, व्हाट इट इज, R1 इज बेसिकली, आपने क्या लिया था, A से B तक, एंड हाउ इट वाज कि 1 इज रिलेटेड टू A, so means R1 of 1 gives you A, R1 of 2 gives you V, whereas A had 3 elements, right? So here R1 is not a function because 3 belongs to A, does not have any related element in B. For example, if you talk about a relation, let's say I write here R4, and that is like 1 comma A, 2 comma A, 3 comma B. So if you observe, each element of capital A is related to some unique element of capital B. Please focus the word unique. means you cannot have one is related to A and one is related to B itself. Similarly, R2 is not a function from A to B, whereas R2 and R3 you can write R4 is a function from A to B. Did you get the point, everyone? What I tried to convey here, basically, whenever you have some set, what you started, you defined the Cartesian product like this. You have defined some relations. Relations are just some subset of Cartesian product. So if you want to represent through the Venn diagram, that may look like this. The smaller one is the function, next is the relation, and next is the Cartesian product. Am I clear to you all? Shabko? Although these are very basic things, but for me, I cannot go like the Hawaii fire. Okay. I must start from the basics. If you know, fair enough, keep on moving. Please note down. After this, I will start the definition for equivalence relation, because the first priority was at least you know what is relation, right? So अभी क्या होगा, अपने लिए जो मेन काम होगा, रिलेशन ऑन अ सेट. फेयर? बिकॉज अपने पास तो एक ही सेट है ना. yesterday we said one set one operation, so we have only one set, so we will be talking about relation on a set. Please note down, everyone. And please, I'm requesting everyone, note down each and everything, then only you will feel the flow. Noted? Rest of the persons, बाकी लोग ने नोट कर लिया? And persons who are newly joined, please do proper note down things. Okay. Rest of the persons, is that noted? Fair, Amit. So अपने को पढ़ना है equivalence relation. Fair. So let's start now the equivalence relation. Fair? So we will write here, as I yesterday told you, ki if you are clear about the definitions in mathematics, you will really enjoy the maths. If you're always running for the formulas, it will be like na, it is always boring. Fair. डेफिनेशन समझिए, बहुत ही बेसिक पार्ट होता है. सो लिखेंगे ए रिलेशन ऑन अ सेट एस, व्हाट आई टोल्ड यू, रिलेशन है ऑन द सेट एस है, दैट मीन्स ऑन द सेम सेट यू आर वर्किंग. ए रिलेशन ऑन अ सेट एस is said to be equivalence relation if नंबर फर्स्ट देखेंगे द रिलेशन, ए रिलेशन इसको नाम दे दूं कैपिटल आर. आर इज रिफ्लेक्सिव. सेकंड, आर इज सिमेट्रिक. नंबर थर्ड, आर इज ट्रांजिटिव. Fair, dear fellows. So what does it mean by reflexiveness? It means each element of S is related to itself by the relation R. ठीक है? And what does it mean by? And it is represented by A is related to A itself. Why R I have taken? Because R is the representing the relation, right? When I talk about symmetric, please understand this word because many of you may have the confusion in your mind. I'm saying if, ध्यान से देखिएगा, if and highlight this word. If A is related to B, then B must be related to A. Means if, इसका मीनिंग क्या हुआ, A is related to B, then B must be related to A. Right, dear fellows? Fair. And please इसको highlight करके रखिएगा. Means if in some relation A is not related to B, then it is not required at all कि for symmetricity B must be related to A. अभी इसको एग्जांपल के थ्रू समझेंगे. यहां पर भी if A is related to B and again with the if V is related to C, then C must be related to A. And how it is represented, my dear fellows? If A is related to B, B is related to C, this implies C is related to A. Right? Now let's understand through an example. ध्यान से देखना आप इस बात को. What I want to say, let S is the set of straight lines. Fair? S किसका कलेक्शन है? स्ट्रेट लाइंस का. ठीक है? We define a relation R as Debu, relation R as parallel to. ध्यान से समझिएगा. What I said कि if two straight lines are parallel, then they will be related. What does that mean? Tell me. This means two straight lines are related by the relation R if those are parallel. फिर so this is the relation we defined. अब S के अंदर में suppose that you have taken straight lines का collection, right? ध्यान से देखेंगे इस चीज को. Now if you take a straight line और parallel की बात करें, so what happens is every straight line is parallel to itself. So what you can say, any straight line is related with itself. Fair? दूसरा, if Li is parallel to Lj, ध्यान से देखेंगे, if Li is parallel to Lj, then Lj will be parallel to Li or not? So what you can say, symmetricity holds. Here reflexive relation holds, right? The next part is, यहाँ पे लिख दूं, if Li is parallel to Lj, is it visible to all? Yes. Lj is parallel to Lm, so this implies Lm will be parallel to Li or not? So इसका मतलब क्या हो गया? Transitive. Fair? Although थोड़ा सा messy हो रहा है, फिर भी I guess you people will manage, right? So what happens when you define the relation R that is parallel and that satisfies this reflexive, symmetric and transitive? So what you can say, this relation is an equivalence relation on the set S. कह सकते हैं या नहीं? कोई दिक्कत यहां से किसी को? So this set, अभी आप इसको नोट कर लेंगे या फिर आई विल स्टार्ट समथिंग. अच्छा, so for example, let's say this is one. I write another example. I take S as the same collection. S is collection of straight lines. Okay. And we define a relation R as perpendicular on S. Means what? Means two lines means elements of S will be related if those are mutually perpendicular, right? And if I ask you, then R is an equivalence relation on S, your answer will be no. Why? What is the reason? Line itself cannot be perpendicular a line cannot be perpendicular to itself. So reflexivity is not holded here. Although symmetricity holds. Why? If L1 is perpendicular to L2, then L2 is perpendicular to L1. So I hope the equivalence relation will be clear to you all now. Is there any doubt? Any student? Shudhakaran, Shundram, anyone? Jitendra? Please note down. And equivalence relation is very important for our abstract algebra. Without this, we will be doing nothing. Okay, Jitendra. Good. आराम से शिबू, आराम से, कोई इशू नहीं है, मेरे को जल्दबाजी नहीं है. प्लीज नोट डाउन प्रॉपरली, because to understand algebra these are preliminaries and very much required. And persons who thought ना कि यार ये अपने को आता है, they will never learn the algebra का crux. Thing is interlinking the thing is the required thing यार, है ना, otherwise तो skipping तो हमेशा ही होगा, कोई इशू नहीं है. And persons who are new, please go through the description how this lecture series is going on and attend this with proper discussion with your teacher. Okay, मतलब randomly hit नहीं करेंगे, because this may be very fruitful if you have the better guidance. Is that noted, everyone? Have you written everything? Okay, Amit, fair. नो प्रॉब्लम शिबू, आराम से नोट कर लो, कोई दिक्कत नहीं है. Okay, Chandram, fair. uh, देखेंगे, please everyone, if you define a relation, देखेंगे everyone, if you define a relation on a set S, it means what? You take some element of this, let's say S1, and you relate this element, let's say with S2, and you represent this by S1 is related to S2. Fair. So suppose that if you have a relation on a set S which satisfy these three properties. What are those? Reflexive, symmetric, and transitive. Reflexive means what? Meaning is this, कि each element of that set should be related to itself, then only you will say that relation is reflexive, otherwise nahi. Fair. So what I found, I defined a relation as parallel to. Fair. Means if I say कि if I have a collection of straight lines, fair, and you define a relation on those straight lines as parallel to, so one line is always parallel to itself. So means the relation parallel to on the set of straight line is always reflexive. Okay. If some line is parallel to other, suppose that this line is parallel to this, then this will be also parallel to this. So this you call, if li is related, sorry, li is, if I am saying if li is related to lj, then lj must be related to li, then only you will say ki relation is symmetric, otherwise nahi. So for parallel as a relation, this is also satisfied, Shundram. Now come on the transitive. Sorry. So when you say ki if A is related to B and B is related to C, then C must be related to A, right? So when I take the relation as parallel to, what I noticed here is कि if Li is parallel to Lj, this is a parallel, right? Lj is parallel to Lm, then Lm must be related to parallel to Li. And that is obviously, like, suppose that if you have these two lines as parallel, third line is parallel to this, then this will be parallel to this or not. So that means the relation parallel to for collection of straight lines defines the transitivity as well. So what you said, the definition of equivalence relation, कि a relation which satisfies reflexive, symmetric, transitive, that is called an equivalence relation. For the better picture, I took another example. Here I took the same set S, okay, but I changed the relation from parallel to perpendicular. Means two elements of the set S is said to be related only when they will be perpendicular to them. So if you talk about equivalence relation, you need the reflexive as well. But is it possible that some line is perpendicular to itself? Not at all. So what you will say, कि this relation perpendicular cannot be a reflexive relation on the set of straight lines. So if one of the property is violated, what you will say, कि that relation cannot be equivalence. Fair? Although you may try कि symmetric है या नहीं है. So you can obviously observe if some line is perpendicular to this, then this will be perpendicular to this as well. So symmetricity hold करेगा, but reflexive नहीं है. That is why that cannot be an equivalence relation. So for this you have an equivalence relation. For this you don't have an equivalence relation. Whereas the set is same, but relation is different. Shundram, is that clear now? Sundaram. Okay, fair. Chale. Now the most important part which is required for group theory that we wanna discuss now. है ना? And end of the lecture you will feel today कि okay why these things are necessary, right? I already told you this series is planned. Okay, fair. अभी देखेंगे. Let's try to get the another subheading here, that is partitioning of a set under an equivalence relation on that set. Let's say if you call that set as capital S. देखेंगे. Let if S आपने जो लिया है, S is the collection of 10 straight lines. ऐसे मान लो. What I said? Collection of 10 straight lines. Fair? और रिलेशन आपने क्या डिफाइन किया हुआ है? पैरेलल टू. ओके, ऑब्वियसली we have seen that this relation is an equivalence relation on S. This we have proved as well, right? In the example 1. So if this is an equivalence relation, so by fundamental theorem, basically this is called fundamental theorem, this relation, let's say if you call that relation R, must partition S. समझेंगे इस वर्ड का मीनिंग क्या है, व्हाट डज दैट एक्चुअली मीन. R partitions S. Suppose that you have defined the R as, let's say you have related with, क्योंकि equivalence है तो reflexive hold कराना पड़ेगा, right? So just I am defining, for example, कि let R is defined like plus let's say L1 is related to L2, then due to the symmetricity L2 must be related to L1. एक ले लेते हैं, let L1 is related to L3, L3 is related to L4, then L4 must be related to L1. ठीक है. अब मुझे अगर मैंने L1 L3 ले रखा है तो ड्यू टू द सिमेट्रिसिटी L3 L1 होना चाहिए, L4 L3 होना चाहिए, L1 L4 होना चाहिए, राइट? अभी आप देखेंगे, सपोज दैट इफ यू हैव डिफाइंड, यू कैन डिफाइन डिफरेंट रिलेशंस ऑन R1. लाइक सपोज दैट दिस इज R1. ओके, I take another relation which is L1 comma L1, L2 comma L2, L10 comma L10. ठीक है. Now if you check, कि whether R1 is an equivalence relation on S or not. What is the question? R1 is an, सुंदरम ध्यान से देखेंगे सब लोग इसको, relation on S. What is your answer should be? You will go for the checking properties. A relation is said to be equivalence if it is reflexive, symmetric and transitive. For reflexive, every element should be related to itself, so it is reflexive, right? check कर रहे हैं अब हम लोग. Since reflexive तो hold कर गया. What is the symmetricity? If you observe here, if L1 is related to L2, then L2 must be related to L1. If L1 is related to L3, then L3 must be related to L1. If L3 is related to L4, then L4 must be related to L3. If L4 is related to L1, then L1 must be L4. So symmetricity भी hold कर गया. Please don't misunderstood this as कि L3 L5 भी होना चाहिए. Not at all. If L3 comma L5 is there, means L3 is related to L5, then L5 related to L3 required. If L3 is not related to L5 given, so अपने को उसके बारे में सोचने का जरूरत नहीं है. Symmetricity will automatically hold. If का meaning is clear to you all, everyone. Why I was focused on that if word. Transitivity पर आते हैं. L1 is related to L2, L2 is related to L1, then L1 must be related to L1. Yes, it is. L1 is related to L3, L3 is related to L4, then L4 must be related to L1. Yes, it is there. बाकी L3 L1 है, L1 L3 है नहीं, L4 L3 है, L3 L4 है नहीं. Okay. If you observe this word, please focus here. Here L4 is related to L3 and L3 is related to L4. So L4 must be related to L4, which is coming here. So transitivity holds or not? Please say. Everyone. What I'm saying is, if word ka meaning and transitivity means if A is related to B and B is related to C, then C must be related to A. Similarly, you can say R2 is also an equivalence relation on the same set S. Right or wrong? So means we may define different equivalence relations on the same set S. Fair. Ab, suppose that if you took R1 as an equivalence relation, then it must partition S. What does that mean by partition? देखेंगे. Partition of S. ध्यान से देखेंगे. S के पास क्या एलिमेंट्स हैं? L1, L2 up to L10, right? So I will write this as, let's say L1 एक क्लास, एक पार्ट कह रहा हूं, ठीक है? यूनियन, ध्यान से देखेंगे. This box here, L1 is a class which contain those elements of S which are related to L1 under the respective relation. So for example, if you talk about partition of S under the relation R1, let's say. So what does it mean? You will have the partition of S into different classes. Okay? What you'll write here is, here L1, this box represents elements. अब आप देखिए R1 के अंडर में L1 से रिलेटेड क्या क्या है? L1 खुद है, L2 है, L2 है, L3 है, L4 है, राइट? और कोई रिलेटेड है? सो फॉर एग्जाम्पल अंडर R1 the class L1 is the collection of what elements? L1 खुद, L2, L3 है, yes, L4. विश्वास दिलाइए. Is it clear to you all? Class S1 is clear or not? Class L1 represents all those elements which are related to L1. ठीक है? अब मैं क्लास L2 पर आता हूं. L2 is related to L1, so this itself submerged into this class. L3 is related to L1, so this itself submerged under the class. L4 is here. Suppose that I write L5 here. L5 से related कोई element है क्या? Only L5 itself. Union L6, Union L7, Union L8, Union L9, Union L10. ध्यान दीजिए, this is called the partition of set S by the relation R1. What does it call? Called as partition of S under the relation R1. Fair? Suppose that you talk about R2. So under R2 partition आपको क्या दिख जाएगा? Tell me. Only L1 खुद से रिलेटेड है, बाकी कोई इससे रिलेटेड है नहीं. Union L2, Union L3, L4, L10. So means a set can have different set of partitions under different relations. Am I clear to you all? But that relation must be an equivalence relation. So fundamental theorem says कि if R is an equivalence relation on some set S, then fundamental theorem says कि that relation will partition that set. Is that clear or not? सबको? Because group theory में without this concept we will have nothing. Please check it out. Partition का मतलब समझे या नहीं? Please note down as well. Once again, देखो, सबसे पहले you should have a set S, fair, and you have an equivalence relation on that set S. Let's say that is R. Fundamental theorem in mathematics says कि if R is an equivalence, ध्यान से सुन लेना अमित कुमार अब, if R is an equivalence relation on some set S, then this relation will partition that set. ठीक है, अब पार्टीशन का मतलब होता है कि दैट सेट कैन बी रिटन, पार्टीशन का मतलब अभी लिखा देंगे, अभी स्पेस नहीं है. पार्टीशन मीन्स यू राइट दैट सेट इन द कलेक्शन ऑफ disjoint sets, union of disjoint sets, that is called partition of S. Fair? So when you said ki okay, let R1 is an equivalence relation, you gave the relation like this, and what you said कि partition of S will be looking like कि there will be one part, उसका नाम रहेगा class L1. L1 class will contain those elements which are related to L1. And practically if you learn this concept, what does it mean, Amit Kumar? सपोज दैट सम पीपल फेवर द ह्यूमन राइट्स. आप सुन लीजिए, आपको जीएस में समझा देता है. सम पीपल विल like favor the human rights, some people will favor the environment, like environmental will disfavor, let's say they will favor the economic development. Some people may favor uh, what I said, this पहला वाला क्या बोला था, human rights. Other is the economic development. So a nation can have two parts. So the class of human rights will consist of those persons which favors human rights. Class of economic development will consist of those people who favors economic development at any cost. So what happens is, if you define a relation, equivalence relation on some set S, then it must be partitioned by that equivalence relation. So for example, I took an equivalence relation on the set S, and what I found, my dear fellow, कि that set part, that relation partitions S into different partitions. So if you observe between this class and this class, you can have nothing in common. Between this and this, you can have nothing in common. Between this and this, you can have nothing in common. So that is why this is called a partition of the set S by the relation R1. अमित कुमार, अभी क्लियर हुआ? Is that clear now? Okay, thank you. Is that noted? Jitendra, everyone, is it noted? See, mathematics is all about, yesterday also I told, it is not about studying 1000 different sets. It is only talking about some fixed sets, relations, then whichever is isomorphic to this, you know about that. So I defined the partition means any relation on a set is an equivalence relation, that will set, that will classify the partition of that set. Is that noted, everyone? Okay, Jitendra. Just write a definition more, please. Partition. Just note करके लिख देंगे. Partition of a set. Let if S is the union of A1 union A2 union A3 union AN, ठीक है, such that AI intersection AJ is phi for I not equals to J. यही मैं आपसे बोल रहा था अभी कि if some set is written as union of disjoint subsets of S, इसको क्या बोलेंगे? S is union of its disjoint subsets, right? So what does it imply? This implies A and AJ are disjoint. This is set empty set, right? Phi is called the empty set. So whenever you are able to write a union for some non-empty set S like this, then you call this as a partition of that set. For example, in the previous lecture, in previous example, what we said, S is the collection of L1, अगला क्या था? L5, right? Since if you observe the class Li intersection Lj is phi, ठीक है, for I not equals to j, क्योंकि if I equals to j हो गया तो फिर तो खुद में और खुद का इंटरसेक्शन for I equals to j means क्या होगा? Li इंटरसेक्शन Li करेंगे वो तो Li ही मिल जाएगा, राइट? So that is why we said for I not equals to j. So what do you call? So is a partition of S Y relation R1. Shundram, Amit Kumar. शिबू जायसवाल, क्लास के अंदर ग्रुप ऑफ एलिमेंट्स कहने का मतलब ये होता है, हियर L1 के अंदर क्या आया था? L1, L2, L3, L4, because these all elements were related to this, and this elements का class can also be written as L2 का class, this can also be written as L4 का class, क्योंकि due to the equivalence relation, क्योंकि रिलेशन अगर इक्विवेलेंस है तो L1 अगर रिलेटेड है L2 से तो L2 भी तो रिलेटेड होगा L1 से. सो इफ यू राइट द क्लास ऑफ L2, L2 से रिलेटेड हो गया L1, एंड ड्यू टू द ट्रांजिटिविटी एज वेल फिर L3 भी आएगा. सो whereas if you observe the class of L5, it has only single element L5. If you observe class of L6, it has only one element under R1. सिबू, अभी क्लियर हुआ आपको कि class is just collection of those elements which are related to that element under that relation. अभी क्लियर है शिबू? इसको याद जरूर रखेंगे क्योंकि कॉन्ग्रुएंस, मॉड्यूलो सिस्टम, everything will be related with based on this only. अरे भाई क्या लिखा है, पढ़ो इसको. टू सेट्स आर डिसजॉइंट्स इफ दे हैव नथिंग इन कॉमन. हिंदी में समझ लो. Two sets are disjoint if they have nothing in common. So if you observe here two classes, they have nothing in common, because अगर कुछ भी common हुआ, suppose that L7 is common between them, तो L7 will come under the class L1 itself. वो यहाँ क्यों जाएगा फिर? So disjoint means there is nothing in common between those sets. पढ़ो इसको जरा. क्लियर है शिव अभी? Is that clear? Is it written? Okay, Shiv. Okay, Chandra. Fair. Please write down this. Please. Is that noted? तो याद रखेंगे, पार्टीशन ऑफ अ सेट मींस पार्टीशन किसी के द्वारा तो हुआ होगा. ऐसे समझ लो आप. इंडिया पाकिस्तान डिवाइडेड ड्यू टू व्हाट? द क्लासेस. सो क्लासेस इज अ रिलेशन. इफ मेरा क्लास किसी पर्सन के साथ है और उसका क्लास किसी और के साथ में है, तो तीसरे वाले का मेरे साथ क्लास हो गया. दैट इज ट्रांजिटिव, राइट? So thing is, this algebra is very much interesting. If you explore, if you take interest in it, right? Everything is related, deep rooted with the practical life. Fair? Partition, disjoint. Disjoint ये है कि भाई जो तुम्हारा वो तुम्हारा, जो हमारा वो हमारा. Means nothing in common. अब मैं खुद से disjoint हो सकता हूँ क्या? नॉट एट ऑल. तो वही बात को मैथमेटिकली लिख देता है कि एल आई इंटरसेक्शन एल आई कैन नॉट बी फाई. मेरे भाई, वो तो एल आई ही रहेगा, है ना? ओके, फेयर. सो so don't close the link. We will start again over the same link. Okay, तो आप हम लोग 10 मिनट का ब्रेक लेते हैं. विल टेक अ 10 मिनट्स ब्रेक, 10 मिनट्स. विल मीट आफ्टर 10 मिनट्स ओवर द सेम लिंक. सो डोंट क्लोज द लिंक, है ना? चलो. All are there? All are there? Should we start the class now? Fair. Cool. Chale. So as today it is the preliminary lecture for the group theory. So I am telling you just basics, just those fundamentals which will be frequently used in this group theory part. Fair. So the next concept which we will be using further, equivalence relation, fundamental theorem is clear to you all, right? Let's move on the next term which we will be frequently using here, that is mathematical induction. Okay, basically it is a method to prove a statement. Okay, for what it is used in the algebra or not in the algebra only, it is widely used in maths. And you know, my dear fellow, this is more about the practical life. If you observe this thing, okay, although अभी like it is not some voice to voice interaction, message में time लगेगा, but we like uh, offline lectures में ना we have very good conversation over that. If you feel the mathematics induction, चलो let's start, है ना? Let's feel it, right? Let's feel it. Because algebra is the most beautiful, algebra and analysis, you know, the most beautiful part of mathematics, I'm saying. पढ़ने पढ़ाने का तरीका सही हो बस, देखना मेरे बच्चे, व्हाट इज मैथमेटिकल इंडक्शन आज के बाद भूलेंगे नहीं कभी. सपोज दैट यू हैव सम लेडर्स, ओके. आई एम सॉरी. ध्यान से देखिए व्हाट आई वांट टू कन्वे हियर, लेट्स फील इट. व्हाट मैथमेटिकल इंडक्शन सेज, सपोज दैट काजल यादव, गुड इवनिंग. इट्स टू लेट, ओके, जल्दी आया करो. चले, सो लेट्स से काजल यादव अभी अभी आए हैं, उन्हीं को ले लेते हैं. सपोज दैट द स्टूडेंट is here. Okay, dear fellows. A student is on this ladder. Fair. And somehow, what you thought? Ki she climbed for this ladder. She also climbed for this ladder. You didn't check whether she traveled through these ladders or not. She climbed these ladders or not. What you suppose? Ki okay, she is here as well. So let's say the student Kazal, she is here and she is here as well. Fair. And if you suppose कि she climbed up to this ladder and you are able to prove what you supposed, ध्यान से देखेंगे, you supposed the student is at this ladder, let's say LK. This is L3, this is L2, this is L1. Let suppose कि the student K is on ladder LK, and you, if you prove K also climbed up to the ladder LK plus 1. समझना इस बात को. What you have done? You checked कि C climbed up to this manzil and you assumed कि C also climbed the manzil LK, the goal LK. And you have shown कि the goal LK plus 1 is also achieved by that student. Then you will state, you will conclude this particular student can achieve any of the goal. That is the mathematical induction all about. What does it says? कि if some statement, अब मैथ्स पे आ जाते हैं. If some statement is true for, let's say, some 1 or 2, that doesn't mean it should be for 1. Let's say it is true for 2. Okay, you have assumed that if it is true for k and you proved that is also true for k plus 1, then you will conclude that statement will be true for any natural number. That is called the mathematical induction method. हिंदी में समझेंगे अगर तो कि अगर किसी स्टूडेंट ने ये गोल अचीव कर लिया और आपने ये माना कि चलो उसने ये वाला एग्जाम क्लियर कर लिया होगा, एंड यू प्रूव्ड कि ओके दैट स्टूडेंट क्लियर्ड दिस पीसीएस एग्जाम and cleared UPSC as well, then you can conclude that particular student can clear any of the exam in this world. That is called mathematical induction. Means पढ़ेंगे इसको, देखिएगा. If some statement is true for n equals to 1, ठीक है, let if that statement is true for n equals to k, and if we prove that this statement is also true for n equals to k plus 1, then mathematical induction says, what it says? कि that statement will be true for any natural number n. Is that clear to all or not? Mathematical induction आज समझ में आया या नहीं सबको? नहीं आया तो फिर समझाएंगे. बोलिए. Shundram, Jitendra, Amit. Where is Ramanuj today? Toshif. Mathematical induction is clear to all or not? If some statement is true for 1, some statement, by letting the statement true for k, you proved that statement is true for k plus 1, then it can be generalized that this statement will be true for any natural number. This is called the mathematical induction method. Okay, Shundram. Everyone. Good. So you felt the mathematical induction. Now please note down, please draw this figure as well. That will give you the clear picture ki what it is actually. Please note down. Noted? Fair. Chalo. So mathematical induction, it is a very favorite tool in pure mathematics, which we will be like using frequently. And please don't forget the sequence. And n equals to 1 can be replaced by anything. Okay? Means you take that as finite number. Okay? Suppose that it is true for 5 and you prove for k and k plus 1. That's it. Let's say, let's take an example from the mathematics itself. Okay? Uh, let's take a sequence of numbers. Square root of 3, square root of 3, fair. Let's say we have a sequence of this, and you give this as, let's say, s1, you say this as s2, you say this as s3, you have some sn, or you can say sk, sk plus 1, and so on. Right? यही तो होगा. Suppose if we want to show that sequence s1, s2, and so on is an increasing sequence. ठीक है? So for increasing sequence, what you have to show? हर अगला टर्म पिछले वाले से बड़ा होता जाएगा. This you have to show. So by mathematical induction method. देखेंगे इसको, बहुत प्यारा सा लीनियर रियल में भी अपने काम आने वाला है. सो हमने क्या दिया? This is square root of 3. This is square root of 3 into square root of 3. So can you observe clearly? S2 तो greater than S1 है ही. Holds or not? बोलो. अरे भाई, this is under root 3. This is what? Under root 3 into 1 point something. यही तो बात है. So let's say if I give it 1.6. So S2 is clearly greater than S1. So what you said? S2 is greater than S1. ठीक है, पहला स्टेटमेंट. Now let if sk minus 1, इसको अगर मैं sk बोल दूं, sk is greater than sk plus 1, let, प्लीज अंडरलाइन देखिए इसको, let if this holds, and then we want to show sk plus 1 will be greater than sk plus 2. And if we are able to show above, we can conclude that it's an increasing sequence. विश्वास लाइए सब लोग. क्या बोला? If sk is greater than sk plus 1, so can you say like this? Sk is greater than sk plus 1. Fair. So sk can be written as under root 3 into sk minus 1, right? This can be written as under root 3 into sk. And for this, what do you want to show? That is under root 3 into sk is greater than √3 इंटू एस के प्लस 1 इंक्रीज कर रहा है, तो सॉरी ये मैंने उल्टा लिख दिया, सॉरी आई एम सॉरी, इंक्रीज कर रहा है ना, so this will be k minus 1, this should be k plus 2. चलिए, although I took a hard example for you, but still I'm pretty sure I will make it very interesting for you, so that you are able to get the mathematical induction here. ध्यान से देखिए, this is not a reasoning or CSAT का question, है ना? If you observe here, S2 is what? देखिएगा, √3 into S1 or not, because this is under S1, right? So SK plus 1 क्या होगा? √3 into SK. SK क्या होगा? √3 into SK minus 1, right? So what you assumed कि √3 SK is greater than √3 SK minus 1, and you want to show कि √3 SK plus 1 greater than √3 SK से होगा. And if you are able to show the above, you can extend this statement for any natural number. Means कि this S1 S2 Sn जितना भी numbers आप आगे बढ़ाते जाएंगे, that will be increasing. ठीक है? So I am not proving the things here, prove it, right? Real analysis में we do this for. But what I am more interested here, because many people they haven't studied the real analysis, for them I would like to tell you कि mathematical induction works for such problems. So I have taken an example for you, not going into the process कि how this particular method will work. That we will be dealing for sure, but at respective times. Please note down. Please note down properly. And again I will say, don't panic, don't be in hurry. टॉपिक्स को सेग्रीगेट करना बहुत जरूरी है. I'm sorry. Please note down properly. Is that noted, everyone? Is that noted? Amit, everyone, is that noted? Okay, Shudra, fair. So I hope the mathematical induction method will be clear to you, all right? One more small terminology we will be using here, that is division algo. because things are na, these are very smaller things which you people ignored from your childhood, right? So write the word next is division algorithm. So what it is called? Let if A and B are any two integers, then there exists an integer q such that A can be written as bq plus r, where r is greater than 0 but less than A, greater or equal to 0 but less than A. Please highlight this. Please highlight this. What I said? For example, if you talk about the division algo, what does it says? Let's say if A is, let's say, 17, कुछ अच्छा नंबर ले, 18 है ना, and let's say B is 4, fair. अब माइनस ले लेते हैं, कोई दिक्कत नहीं. So what you can say, 18 can be written as -4 into 4. I'm sorry. This can be written as, check it out, लिखा जा सकता है या नहीं? So what you said, that is, there exist q equals to 5 such that A can be written as bq plus r, where r is 2. That is called remainder. I hope it will be clear. So division algo, what does that say? Please do remember this, because this will be frequently used in algebra. Algebra is all about your childhood memories, but thing is you didn't prepare that in right way, so you always feel the awkwardness here. So this is division algo. Please note down. Okay, Shibu, fair. Okay, Amit. Chalo. There is a very good concept, that is modular arithmetic, or you can say it as modulo system. ठीक है. R equals 38. What you are saying? Why? 38 कैसे जाएगा? Jitendra, what you are saying, please? Can you repeat it? Remainder will be always less than the number in the left hand side. Remainder उससे बड़ा कैसे हो जाएगा? नहीं तो उतने टाइम डिवाइड कर देगा फिर से. Did you notice that point? I said R is greater or equal to 0, less than A. जितेंद्र, इज दैट क्लियर? हाँ, तो -20 प्लस आर लिखा तो व्हाट यू सेड? अच्छा, ओके ओके। Sit. I got your point. The thing is, what he's saying is, what the number is. mm, Jitendra said that was -4, I guess, है ना? What I said? A का value they have. Okay, Jitendra, now I got your point. I was mistaken there, है ना? No issues, please. A is 18, B is -4. So if I do that, fair. So 18, it can be written as -4. Just give me 1 minute, please. I guess I was mistaken over that. So if it was अच्छा, पिछले वाले एग्जाम्पल में एक चीज मैनेज कर लेंगे. आई विल गो फॉर अनदर एग्जाम्पल. द प्रीवियस एग्जाम्पल, प्लीज डू दैट +4 एंड सपोज दैट इफ यू राइट दैट एज, पहले तो आप उसको चेंज कर लीजिए, फिर आई विल गो फॉर नेगेटिव. प्लीज नोट डाउन दिस. इन द प्रीवियस एग्जाम्पल प्लीज चेंज इट. ठीक है. प्लीज चेंज दैट 4 हियर, q की जगह 4, ओके, एंड r की जगह 2. If the both integers are positive, then the division algo will become like this. Now let's discuss about the negatives for the integers. But quotient cannot be negative. Just give me 1 minute, I'll rectify that first, है ना? एक बार just change that example here, and with this time I will be moving with the modular arithmetic, or same time I'll be thinking about that. I will come on that. Okay, Jitendra? Well, I will come with the better explanation. Just let me check it, है ना? हो सकता है, like maybe the mind is twisted. No issues. Okay, with v as positive. I'm sorry. What happens is that is what I missed that. Please rectify. Previous definition. If we have an integer a and positive integer b, then we can find integers q and r such that r lying between 0 and b and A can be written as BQ plus R. I'm sorry, I guess I have like mistakenly written there. मैंने positive integer तो लिया था, but took that in a different manner. So please underline here. Previous वाला definition को या तो rectify कर लीजिए या write down this again. Please, I'm sorry. It happens sometimes. Anyways, I take the responsibility. Okay. Thing is, when we talk about the division algo, ध्यान से देखेंगे. A can be any integer, means negative or positive. Explain कर देता हूँ मैं अब इसको. A can be negative or positive. Positive integer B कैसा होना है? Positive. And Q and R are integers, right? Q कैसा integer है? That may be negative or positive, but R देखेंगे अगर तो वो 0 से बड़ा है. R is greater than 0, so always the positive integer. I guess abhi the picture will be clear, right? King Suk Day. 0 is less or equal to what? King Suk Day, आपका मैसेज क्या है? मैं नहीं समझ पा रहा हूँ. R is greater or equal to 0. अच्छा, हाँ, रिमाइंडर 0 हो सकता है, उसमें कोई इश्यू नहीं है. R can be 0, रिमाइंडर 0 हो सकता है, that is okay. Fair, King Shuk Day. I hope now it will be clear. Sorry for that. Please note down now. So abhi, for example, if you take A as minus 18, so it can be, and suppose that you took A as minus 18 and B as 4. So minus 18 can be written as minus 4 into 5, right? So minus 20 plus का 2. माइनस 4 क्यों ले लिया मैंने? 4 into minus 5. Right? Plus का 2. So this is the positive integer. This may be negative. This may be Q. This is R. I hope now it will be clear to you all. Fair? Division algorithm. And please do remember what is the role of these things here, because whenever we will be proving the theorems in this algebra, division algorithm is the most important, very crucial tool for us. We cannot ignore this. So that is why I was always like focused on that. Ki what is it actually, that should be clear to, है ना? तो जहाँ पे गलती थी, I rectified that and came back over that. Sorry for the disturbance. Is that clear now? Is that noted, Sibu? Thank you, King Suk. No issues. Chal. So let's come on a very fantabulous system, that is modular system. Okay, Chandra. Uh, anyone can tell me what is actually, what do you know? What do you have idea about modulo system? Anything practically, just to make this feel you concept this. Anyone? Just participate. Matlab, where you have noticed actually is in the practical life, anywhere you have noticed the modulo system, then tell me please. Chitendra, tell me where the modulo system you have observed in your life. See, sorry, let's start from the UPSC itself. Let's say this is the godfather, UPSC. Okay, today you will learn the modulo system. Let's say you denote the prelims by 1, है ना? You denote the mains by 2, you denote the interview by 3. ठीक है? So what happens is, if you have qualified the prelims, you will write the mains. If you qualified the mains, you will go for the personality test. And if you clear this, थोड़ा समझना, if you cleared, you are out of this box, right? But what happens? I'm sorry, there are many guys like me, na? Now I enjoy this circle, and at those days I was like you. Whenever I was out of the final list, I was always thinking कि यार life बर्बाद हो गया करके, right? But now I have a fun in my life. So can you observe 1 2 3 1 2 3 1 2 3? So this is, until unless you are not out of the circle, out of this vicious cycle, this is something like a modulo system. गोली मारो इसको जरा, बॉच पर आते हैं. Let's say this is the botch. Here it is 1 12 1 2 3 4 5 6 7 8 9 10 11, right? So basically this modulo system started from the clock or botch itself, right? अच्छा, suppose that घड़ी में अभी there is a time 1 o'clock, then 2 o'clock, then 3 o'clock, 12 o'clock. So you may have a 12 hours watch, right? I'm talking about 12 hours watch. So what happens when you say 13 बजा है? 13 का मतलब what you say? 1. You getting? If someone says the time is 15, what does that mean? If someone says the time is 6, what does that mean? If someone says रात का 24 बज गया है, so what does that mean? 0. Why you write that 0 or the 12 itself? Did you get the point? So basically this clock works on the modulo 12. किस पर काम करता है? Modulo 12 के ऊपर. If you have 15 o'clock, so that means you divide the 15 by 12, and whatever the remainder is, that will be the right answer. This is called remainder when 15 is divided by 12. Suppose that you have said 16 baja hai. So if actually someone wants to know what he should know, you should divide the 16 by 12, and whatever the remainder you get, that will be the actual time. So suppose that you have said 13 o'clock. So means if you divide 13, what is the remainder? That will be the actual time. सिबू, कोई जल्दबाजी नहीं है मुझे मैथमेटिक्स में जाने की. Definitions I am more clear, है ना? But thing is, if I can generate some interest in you to learn this definition, then my job will be actually done. Otherwise, it's of no use, right? So I am just trying to make you feel कि from where the modulo system originated, right? So अपनी कॉपी में ये सब जरूर लिखेंगे. Please note down properly so that if you want to make some Rixopolar to understand the modulo system, you can. Please note down this. I hope it will be clear to you. And please do let me know if it is noted, okay? Is that noted? अरे प्लीज डू रिप्लाई भाई, बताओ तो. सुंदरम, शिबू, एवरीवन. ओके. देखेंगे, अभी हमने फील तो कर लिया इसको. अभी लेट्स अंडरस्टैंड मैथमेटिकली, है ना? देखेंगे मैथमेटिकली मॉड्यूलो सिस्टम को कैसे रिप्रेजेंट किया जाता है. लेट m बी सम पॉजिटिव इंटीजर. यहां पर एक एक वर्ड का मतलब होता है. अलजेब्रा इज ऑल अबाउट, यू नो, when I got into my research at IIT Delhi, then I got to know PhD is what? PhD का definition is learning smaller things at higher level. है ना? This is all about the research. So algebra is all about learning those basics which you have been using since a childhood and now trying to prove those things, right? So here every word matters. So please highlight this. Let m be some positive integer, है ना? अभी हम क्या करते हैं? For example, let if m equals to 5, है ना? So we will write, since integer है, so इसके suffix में 5 लिखेंगे. It is just a set, okay? It is just a set. It is what? Collection of all those elements which have their independent existence in this system. Learn this प्यार से. देखो, 0 का कुछ नहीं कर सकता ये Z5. 1, 2, 3, 4. Since 5 in modulo 5 कैसे डिनोट होगा? Remainder when 5 is divided by 5, what you will get? 6 in modulo 5 कैसे रिप्रेजेंट होगा? Remainder when 6 is divided by 5. 23 कैसे डिवाइड? Remainder when 23 is divided by 5. So what you people are suggested कि Z5 जैसा कि आप बुक्स में देखते हैं कि Z5 is 0 1 2 3 4. No, this is a class. This is a class. This is a class. ठीक है? For example, the class 1 has the collection of elements. 1 खुद को रख रहा है, 6 को भी रख रहा है. किसके मॉड्यूलो में? 5. दिस रिप्रेजेंट्स द मॉड्यूलो 5. 11 को भी रखेगा यही क्लास, 16 को भी रखेगा. फॉर एग्जाम्पल, इफ यू वांट टू राइट 2 इन मॉड्यूलो 5, तो ये 2 को रखेगा, 12 को रखेगा, फिर 17 को रखेगा, एंड सो ऑन. Did you get the point, everyone? What I tried to convey here? कि whenever you say the modulo system के अंदर में you will have classes. Classes means that is not a single element, that will have infinite number of element. Did you get the point? Means infinite number of elements. I hope this will be clear to you all. So whenever you say Z7, let's say you write Z7. So Z7 is लिखा दिया जाता है ऐसे. It is written like this, but basically it has the meaning कि it has classes 0, 1. Okay, where if you ask me what is 1 here, so 1 has the collection of elements 1, 8, 15, 22 and so on. Means if you change the modulo system, the collection will be changed. देखिए यहां पर 1 अंडर मॉड्यूलो 5 के एलिमेंट्स क्या हैं, 1 अंडर मॉड्यूलो 7 में एलिमेंट्स क्या हैं. आई होप इट विल बी क्लियर. विश्वास लाइए. Are you getting my point? When I say Z5, what does that sense? When I say Z7, what does that sense? And how these numbers are coming? Please note down. आराम से लिख लेंगे इसको. अरे भाई शिबू, इसके अंदर लिखो हिंदी में, दिस इज कलेक्शन ऑफ दोज एलिमेंट्स which gives remainder as 1 on dividing by 7. अब समझ में आया शिबू? For example, this is what? This is collection of elements which gives remainder as 2 on dividing by 5. आप समझ में आया शिबू? 1. This is collection of those elements which gives 1 on dividing by 5. अभी क्लियर है? Is that clear now, Shibu? Okay, good. समझ में आना चाहिए. So modulo system, I hope you have clear, right? And again I will say, each modulo system has its universe. ध्यान रखिएगा, Z7 में 2 का वही मतलब नहीं है जो कि Z5 में है. 2 represents different universe in modulo 5 system than 2 represents a different universe in modulo 7 system. Please grab these words. वो दिखते एक से हैं, इसीलिए मैंने लिखा कि here 2 is not simple integer. Here 1 is not a simple integer. It represents basically a class, means collection of infinite number of elements. Did you get this point, everyone? तो आगे फिर गलती तो नहीं करेंगे. अगर आपसे कोई कहे कि Z5 सबसेट है Z7 का, किसी ने पूछा अगर, तो उसको भारी भरकम भगाएंगे, बोले हटो, कैन नॉट बी कंपेयर्ड. लिख लेंगे अपनी कॉपी में. आंसर इज नो, because Z7 has a different universe, Z5 has a different universe. Nothing can be compared here. Are you getting my point? So वो लिखने का, नंबर लिखने का कतई मतलब नहीं होता है. वो तो हम जैसे एक नोटेशन लेते चले जाते हैं, एंड वी ऑलवेज इन द हैबिट मगिंग अप ऑफ द थिंग्स. बट टुडे आई मेड यू क्लियर कि व्हेनेवर यू से Z7, फिर वो पूरा यूनिवर्स है, उसके अंदर 6 रिप्रेजेंट्स अ यूनिवर्स अपने आप में. तो इस टाइप की गलती नहीं करेंगे. I hope it will be noted, right? It is noted, everyone? And please do this highlight. रेड पेन से इसको लिख देंगे. लिख देंगे, टू डिफरेंट मॉड्यूलो सिस्टम्स कैन नॉट बी कंपेयर्ड. प्लीज राइट ऑन द टॉप ऑफ द पेज, टू डिफरेंट मॉड्यूलो सिस्टम्स कैन नॉट बी कंपेयर्ड. और प्रैक्टिकली इफ यू वांट टू लर्न, सपोज दैट इंसान इस गोले पर भी है और इंसान दूसरे गोले पर भी है. लेकिन वी कैन नॉट कंपेयर दोज इंसान, दोज पीपल एज द एट्रीब्यूट्स. हमारे लिए ह्यूमैनिटी कुछ और हो सकती है, वो आमिर खान दूसरे गोले से आएगा तो ह्यूमैनिटी कुछ अलग रहेगा, राइट? So I hope this will work as a best example for you. Aliens, although we all are human beings, but we cannot be compared on the basis of attributes. So this is what the modulo system says. कि two different modulo systems cannot be compared. Is that clear to all? आगे आएंगे. It is not the end of the modulo system. It is just the starting. Okay. Write the next heading. वो अंडर दिस मेन हेडिंग ही होता है. लिखेगा कॉन्ग्रुएंस. लिखेगा. प्लीज राइट डाउन हेडिंग कॉन्ग्रुएंस. मॉड्यूलर अरिथमेटिक का सब हेडिंग रहेगा कॉन्ग्रुएंस. बोलो. देखिएगा. लेट इफ n is some positive integer. सबसे पहला काम क्या लिया? लेट n इज सम पॉजिटिव इंटीजर. ध्यान से देखना, बिकॉज मॉड्यूलो सिस्टम चाहेंगे तो लिख लेंगे मॉड्यूलो सिस्टम डिफाइंड फॉर पॉजिटिव इंटीजर. Z5. Z -5 कुछ नहीं होता है, ध्यान रखेंगे. हालांकि उसके अंदर एलिमेंट्स आएंगे दैट वी विल लर्न नाउ, although that will contain negative integers, that is not an issue. So what we will say, then two integers a and b are said to be congruent to each other in modulo n if a minus b is divisible by n. ध्यान से देखेंगे इसको. फॉर एग्जाम्पल देखिएगा, 5 is congruent to 7 in modulo 2. क्यों? Since 5 minus 7, that is minus 2, which is divisible by 2. Similarly, you can write 5 is congruent to, ध्यान से देखेंगे, 5 is congruent to let's say 12. किस में? मॉड्यूलो 2 में. Why? अच्छा 12 तो नहीं होगा, सॉरी. If I say 5 minus 11, let's say 5 is congruent to, अदर वे भी होता है, 11 भी congruent लिखा जाएगा. Just we will learn that. Since 5 minus 11 is divisible by 2. For example, 6 is congruent to, let's say 1 in modulo 5. Why? Because 6 minus 1 is divisible by 5. I hope the relation congruence will be clear to you all. विश्वास लाइए. When you say the congruence relation, any integer a and b are said to be congruent if a minus b is divisible by n. और ख्याल रखेंगे, प्लीज अंडरलाइन, in like they will be congruent with respect to some modulo system, a specific modulo system. Did you get my point? So please highlight these things, because otherwise you may, क्या है, a and b are integers हैं, congruent कहे जाएंगे with respect to specific modulo n. For example, यहीं पर if I would like to write 6 is congruent to 0 in modulo 6. Why? Since 6 minus 0 is divisible by 6. Did you get my point, everyone? इसके बाद में और लिखना चाहेंगे अगर 6 is congruent to 12 modulo 6 as well. 6 is congruent to 6 modulo 6 as well. 6 is congruent to 18 modulo 6 as well. Shivu, Amit, everyone, is that clear or not? Congruence relation. Okay, Shundram. Okay, Amit, fair. And again, I'll say, whoever new to the lectures, please go through the description, attend the strategy session, how this lecture series to be attended. Don't take it lightly, okay? Baki, I will not boast myself. If you feel it, join it, continue with it, otherwise, enjoy. So, congruence relation is clear to you all, everyone? Please note down this. Okay, Jitendra. अभी इसको हटा दूं? Is that noted? Okay, Jitendra. Fair. And you know why I like always like takes this much joy in this algebra, because I know how the things are related, interconnected, you know. Acha, today's lecture I started from set से relation, equivalence relation पे आके let's finish this lecture on that node only, and that is the beauty of feeling this algebra. Write down the exam point, please. Congruence relation in some modulo system is an equivalence relation. बॉक्स में बंद कर लेंगे इसको. Can you think of everyone how I said this? Tell me. What you said? Let's say. देखिएगा. Since A will be always congruent to A modulo n. Let modulo system is n. Since each element will be क्यों? Because A minus A is divisible by n. So what you can say? इसलिए congruence relation is reflexive. क्योंकि रिफ्लेक्सिव रिलेशन कम होता है when every each element related to itself. So you said each element is always congruent to itself. Each element is congruent to itself in any modulo system you're working, right? So did you get the idea? Reflexive. Second, Shundaram, let's catch it. What you said? कि if A is related to B, देखना, if A is related to B under the relation congruence, this implies A is congruent to B modulo n and B is related to, then it is also true that B will be congruent to A modulo n. क्यों मेरे भाई? A minus B is divisible by n, then B minus A is also divisible by n. So what does this says? Symmetricity is also being held here. किसके द्वारा? By congruence relation. So what the things you have shown? Number first, congruence relation is always reflexive. Congruence relation is always symmetric. यहां तक किसी को दिक्कत है तो बोलेंगे, नहीं तो कहेंगे रिपीट कर दोगे, फिर मुझे मतलब मुझे ऐसा लगता है कि यार बीच में पूछ लेते, पूरा रिपीट करने का मतलब समझते ना भाई, बच जाती है एकदम। ठीक है, सॉरी। इफ यू हैव एनी डाउट टिल हियर देन प्लीज आस्क। क्लियर? बोलो यार। थर्ड पॉइंट पर आएंगे, ट्रांजिटिविटी। क्या बोलेंगे? इफ A is congruent to B modulo n and B is congruent to C modulo n, then it's true C minus A is also divisible by n. That is, C is congruent to A in the same modulo system n. So what you said? कि congruence relation follows transitivity as well. So congruence relation क्या क्या follow करता है? Reflexivity, symmetricity, transitivity. So on combining first, second, third, we state congruence relation is an equivalence relation. I hope it will be clear to you all. कॉन्ग्रुएंसी क्लियर है या नहीं सबको? प्लीज नोट डाउन प्रॉपरली, नो हरी नथिंग, आराम से नोट कीजिए. Okay, Amit. What about others? You have noted or not? Rest of the persons, please say yes or no. Fair. Okay, King Shuk Day. Fair. Okay, Shibu. Fair. That's cool. चलिए. अभी देखेंगे. Please write an exam point, please. Congruence relation partitions the set of integers. इसको नोट डाउन कर लेंगे बॉक्स में. This is called what? Fundamental theorem. Because fundamental theorem says what? If R is an equivalence relation on some set, then this relation partitions that set. For example, अगर समझना चाहें, partition of Z, that is what? Set of integers in Z5 in modulo 5. So कैसे लिखेंगे? This is nothing but the equivalence class 0 union equivalence class 1 union equivalence class 3. बोलिए आप. इस दुनिया जहां में कोई ऐसा इंटीजर होगा जो इन क्लासेस में से किसी एक में नहीं आएगा. बोलो. अभी समझ में आया? इक्विवेलेंस क्लासेस. If some relation is an equivalence relation on some set, then this is an equivalence class, right? This is an equivalence class. ठीक है? Which contain, किसको किसको रखेगा? 0 को रखेगा, 5 को रखेगा, 10 को रखेगा, 15 को रखेगा. 1 किसको रखेगा मॉड्यूलो 5 में? बोलो. 1, 6, 11, 16 and so on. So I hope now you people will be clear about why I have told you about the relation, why I told you about equivalence relation, why I taught you fundamental theorem, what is the meaning of this. Also, these classes are distinct. You can observe कि इंटरसेक्शन ऑफ दिस क्लास इज फाई और नॉट. बताओ इन दोनों में कुछ कॉमन आ रहा है क्या? एनीथिंग इन कॉमन? नॉट एट ऑल. You can observe class 1 intersection class 2 phi. So what you say? These are disjoint classes. Sibu, did you get the fun in this or not? Everyone, if you have any doubt, please do ask. Please note down. Right. If you take 6, then you would not be correct. King Shuk Day, right? We will learn that as well. We will have all the funs in the coming classes. है ना? We'll enjoy for sure, for sure. Primes, non-prime, composite numbers, everything, right? But today it is the preliminary. At least you have an idea about the modulo system. What is congruence relation? What is the equivalence classes, right? King Shuk Day. Did you get my message? अरे 4, अरे सॉरी, 4 कहाँ जाएगा? अरे सॉरी, Z5 में 5 तो यहीं आ गया ना. आई एम सॉरी. मॉड्यूलो 5 है ना, तो क्लासेस तो 4 तक जाएगा ना. 5 तो 0 में ही आ जाएगा. देखो, सॉरी फॉर दैट, है ना. ओके, फेयर. Shibu, Shundram, everyone, is that clear? Today's class, I tried to like make this as interesting as possible. Okay, Shibu, fair. So for the preliminaries part, almost the things are covered, whichever the terminologies we will be using in next lectures. Only number theory wala bit information needed, that I will convey at the next lecture. But preliminaries के लिए the things are over. ठीक है? So it's enough from my side. If health, अभी तो like I took the medicine that class के starting में you found me very lethargic, right? I was not energetic. After taking the medicine I got energy, so I continued the lecture. पता नहीं कल को क्या होगा. ठीक है? So thing is, tomorrow if I'm health wise very good, I will take the lecture tomorrow as well. If anything happens with the health, I will say sorry, but मुझे उम्मीद है कि कल भी मैं लेक्चर ले लूंगा. ठीक है? I will discuss in the group itself, है ना? If I will take the lecture, please check the notification और telegram group में I will state कि कल relation, कल lecture होगा या नहीं होगा. क्योंकि हम मतलब कल ऐसा कर सकते हैं, PYQs का भी सेशन रख सकते हैं. We will discuss in the group as per the schedule, whatever given in the schedule we will follow that. ठीक है. वैसे कल हमारा क्लास है नहीं एज पर द शेड्यूल, राइट? फ्राइडे क्लास है क्या हमारा? मंडे, ट्यूसडे, वेडनेसडे ऑफ, थर्सडे, फ्राइडे. मुझे पता नहीं है शिबू, फ्राइडे वी हैव लेक्चर और नॉट? एक बार शेड्यूल चेक करके देख लेंगे क्या? जस्ट लेट मी चेक द शेड्यूल. फ्राइडे ऑफ है हमारे लेक्चर में, ठीक है. तो फ्राइडे इज ऑफ. फॉर द ऑफ क्लास आई विल notify in the group, so do join the telegram group, or like you can ask over the 8:30 और 9 को कि एक्स्ट्रा क्लास रहेगा कि नहीं. वैसे तो मैं ग्रुप में इन्फॉर्म कर दूंगा, ठीक है. एक्स्ट्रा क्लास आई एम प्लानिंग PYQ सेशन रख सकते हैं वेक्टर कैलकुलस का. तौशीफ, दैट विल बी फेयर और नॉट? हाँ, आर यू देयर? ओके नमित, चलो. सो प्लीज कीप लर्निंग, कीप स्माइलिंग, है ना. आई एम ट्राइंग माई बेस्ट एंड ऑल्सो होपिंग द सेम फ्रॉम योर साइड एज वेल. Good luck, everyone. Good night. If you want to talk to me, you can talk over my number 9971030052. Okay. Good night, everyone. हाँ शिबू, आई चेक्ड. अगर एक्स्ट्रा लेक्चर मुझे रखना होगा, PYQs का सेशन आई एम प्लानिंग फॉर द वेक्टर वाला, ग्रुप में डिस्कस करेंगे. अगर आप लोगों ने उनके क्वेश्चंस को ट्राई कर लिया होगा, if you people have tried all those PYQs of Gauss divergence stocks, then I will take extra session just to take your doubts. Otherwise we'll have some on some other day. ठीक है, अभी एंड करें सेशन को. गुड नाइट एवरीवन, गुड नाइट. यस सुंदरम, थैंक यू. I'll try. Good night Namit, good night. Good night Jitendra, good night King Shukde. Good night everyone. If you have any doubt you can ask, otherwise it's okay. If you have any general query you can ask over the phone itself, है ना. Fair? Cool. Good night.